Welcome back to Allen High School, and you all know that you are this. All right, let's go on. And we're going to jump in and fill this little chart that you have in your notes. Now, these energy levels, you can think of them as, well, they are, just like the Bohr model. That's the best contribution that Bohr gave us to atomic structure. Now, within each energy level, we have sublevels. And energy level 1 can have S, 2 can have S and P, 3 can have S, P, and D, and 4 can have S, P, D, and F. And you notice that energy level 1 has 1, energy level 2 has 2, 3 has 3. Those patterns will help you, but the periodic table is going to help as well. Now, for the orbital diagrams, we use lines to depict it instead of a symbol. So the S has one line. Now, it doesn't matter if it's 1s or 2s or 3s. It has one orbital associated with it because there's only one way you can orient a sphere. Now, the P has 3, so we'll just use 3 lines. Now, we're going to use this some. You're going to do some diagrams. This is very helpful, but you'll see fairly quickly that this gets to be kind of cumbersome. That's a good SAT word that we put in your notes for you. And again, it doesn't matter whether we're talking about which energy level we're talking about. Sorry, I had to hush my husband on that one. Now, it still has 3, and then the D has 5, and so on and so on. So I think you get the pattern. Sorry, I'm not doing my lines real well. And then the F has 7. So we would have 7 lines for the F. And just because I won't have room, let me stack them like that. That'll look a little better. So the F is going to have 7 lines. So there's 4, 3, that's 6, and 7. And now, electrons per sublevel. Well, we can have 2 electrons in each orbital. So the first has 2 in this sublevel, and since there's only one sublevel, it's 2 per energy level. And this has 2. Whoops, I should have used the arrows for you there. This one has 2. And we're going to use an up arrow and a down arrow. You'll see that in just a minute why I'm doing that, but I wanted to give you that number there. Now, this one also has 1, 2, 3, 4, 5, 6. So that's going to have 6. So 2 in the S plus 6 in the P gives us 8 in the energy level. Or you can remember 2n squared gives you the number of electrons in an energy level. Okay, so this has 2, remember, and I'm going to talk about these arrows in just a minute. 1, 2, 3, 4, 5, 6. So that gives us 6. D can have 10, 2 per orbital. So if we add up the whole energy level for the third energy level, we have 18. Well, 3 squared is 9 times 2 is 18. Here we'd have 2 and 6 and 10. And now if we add the F's, we have 14. And if we add all those up, we should get 4 squared is 16 times 2. Should that be 32? Okay, so these are numbers you probably saw back in middle school. But now we're going to try to pull it all together in a little bit more detail. Now, I used arrows a minute ago. I think I wanted you to see that we could put 2 electrons, and as long as I was doing that, I wanted to show you the proper way that we do that. Now, electrons, what they can do is in the presence of a magnetic field, they will orient themselves. Now, we don't really know, as far as I know, whether these are truly spinning, but they have some sort of magnetic moment because they're charged and they're moving. Things that are charged and things that are moving have their own little baby magnetic field. So they each have their own little, my Mimeo is not working for me today, folks. I'm sorry. They each have their own magnetic field. So when you take their magnetic field and put it in an external magnetic field, the first one's going to go in with the magnetic field, so we call that spin up, and the other is going to go against it. So it's plus 1/2 for the up, minus 1/2 for the down. Now, this gives you one final analogy before we build into an orbital diagram, and how we can envision this is that N is much like our stadium level, right? You're going to be spending more money, aka more energy, to get into different levels in a stadium. L is going to equal our section within that stadium level. So that would be a section. And then M sub L would be our row. And then M sub S would be the seat within the row. So now if we had all that information, that would be enough information to find you at a football game. And now there's 90% probability you're going to be in that seat. You know, you may be up going to the bathroom or getting some food or something to drink, but there's like a 90% probability we're going to find you in that seat during the game. So again, our energy level, remember that's distance. So usually the levels get less expensive as they get further away. So higher energy to get up the stairs. And L's our section. Remember, that's our shape. And you notice each of these sections kind of have their own shapes. M sub L's the row, M sub S is the seat. And it's all about finding that elusive little electron. Now, I'm going to go ahead and stop this one a little early, and that way we can start filling in our models in the next one. So until then, this is signing off.